Hello, Geometry Advanced students. So today's lesson is going to be a review of circumference and arc length. So we're still in our circle unit. And again, we've talked about arc length and area of a sector before, but this is going to get into a little bit more depth of it. So two objectives here for today. One, we're going to determine the circumference of a circle, and two, determine the arc length of a circle. So circumference of a circle is referring to its perimeter, but we don't say perimeter of a circle, we refer to that as the circumference. So the formula for circumference is either pi times diameter or 2 pi times the radius. Okay, so we are going to look at this particular example. It says we are given that segment AB is 20 and segment PQ is 2. So if I label the problem here, PQ is going to be 2. If I extend PQ so that it goes through the center of the circle, which is O, and out the other side, remember, I was a right angle here, so if a radius, for that matter, is perpendicular to a chord, it also bisects the chord. So if AB is 20, AQ and BQ are both going to be 10. So what I'm going to do first, I know it asked me to find the diameter of the circle. I'm going to call this length here x, and I'm going to use the chord power theorem to help me find x. So if we do that, remember our chord power theorem, the product of the segments of one chord is equal to the product of the segments of the other chord. So we're going to have 2 times x equals 10 times 10. Well, 2 times x is 2x, and 10 times 10 is 100. And if I divide both sides by 2, x is going to be 50. So if this length here is 50, that means the whole diameter from P out to here, we got to take 50 plus 2. So the diameter of the circle is going to be 52 units. So if I knew the diameter, I could find circumference. Okay. Continuing on here, our other theorem, or I should say our theorem for today, is the length of an arc is equal to the circumference of its circle times the fractional part of the circle determined by the arc. So basically, and we've talked about this before, it's a fraction of the circumference. Okay, so if a circle, we shouldn't say if, a circle is 360 degrees all the way around, so I'm going to put my arc over 360 and multiply that by the circumference. Pi times diameter, or you could do 2 pi times the radius. It's completely up to you. So in this particular example, it says to find the length of arc AB. So I'm going to go from A to B. It's labeled with 2 letters. That means it's the shorter distance between the two. So we know in the picture that angle AOB is 90. We've got a right angle here. So 90 over 360 is 1/4 of the circle. So I want 1/4 of the circumference. And it shows me in here the radius is 4. So that would tell me the diameter all the way across would be 8. So I need 1/4 of 8 pi, because again, circumference is either 2 pi times the radius or pi times diameter. And 1/4 of 8 pi is 2 pi. Okay, in the second part, it says find the perimeter of sector AOB. So what that is referring to, if I have sector AOB, I have that region there. I'm not trying to find the area, I want to find the perimeter. So the arc length from A to B here is 2 pi, and then I have to add on these 2 sides, which in this case, they're both 4, because radii of a circle are congruent. So the perimeter of sector AOB is going to be, 4 plus 4, which is 8, plus the arc length, which is 2 pi. Okay. If we continue along to look at the next example, it says the diameter of a bicycle wheel, including the tire, is 70 centimeters. So for part A, how far will the bicycle travel if the wheel rotates 1,000 times? So if you're rotating the wheel, you're going around the circle, which is again circumference. So we are going to find circumference. Circumference is going to refer to 1 time around. And again, we need to figure out what 1,000 is. So let's do 1 first. So circumference is again pi times diameter. and it tells us the diameter is 70 centimeters. So if I take pi times 70, that's just 70 pi. Okay. Now, continuing on here, I want to figure out, again, how far it travels in 1,000. So this is 1 revolution. And again, I'm trying to figure out 1,000. So I'm going to take 1,000 times 70 pi, which as an exact answer, it would be 70,000 pi. But, and I should have units here, so I'm talking about centimeters. And if I wanted a more exact answer, I could use my calculator and type in 70,000 times pi. So an approximated answer would be 219,911. So depending on what the directions say, again, the 70,000 pi would be your exact answer in centimeters, or 219,911 centimeters. Part B, it says, how many revolutions will the wheel make if the bicycle travels 15 meters? Okay, so let's make a conversion. Hopefully everybody remembers how many centimeters are in a meter. There are 100 centimeters in 1 meter. So if I'm talking about traveling 15 meters, that's going, so 15 meters is equivalent to 1,500 centimeters. Okay, so, excuse me, if 1 revolution is 70 pi, I'm going to take 1,500 and divide it by 70 pi. Again, if you're doing this in your calculator, you're going to want to put the 70 pi in parentheses, otherwise your calculator is doing order of operations. So I'm going to get 6.8 revolutions. It would make more sense to round to the nearest revolution, so I would say approximately 7 revolutions. Not exactly 7 or a little short of it, but about how many, I would go with the 7. So again, today we are focusing on circumference and arc length. So your assignment for today is in the textbook, or on page 501. You're going to do numbers 2, then 4 through 6, so 4, 5, and 6. And then when you get to number 8, you're going to start the evens, 8 through 16 even. If you have any questions, please let me know.